A conducting rod of length L is moved at a constant velocity v0 on two parallel conducting smooth fixed rails that are placed in a uniform constant magnetic field B perpendicular to the plane of the rails as shown in figure. Here inward magnetic field is given. Okay, a resistance capital R is connected between the two ends of the rails. Here this is the two rails and one ends are connected through this resistance. So resistance R is connected between the two ends of the rail. Then which of the following is incorrect? So we have to find incorrect option. In such questions, you have to be a little bit extra cautious while selecting the options, because you have to disregard the correct options, because here it is in this question that which of the following is incorrect. Okay, so now here we can see that it is moving with the velocity v0 and we have to maintain the constant velocity v0. So EMF across the ends of this rod in this case will be B into v0 into L. Okay, B into v0 into L will be the EMF developed across this rod, and because of this EMF, current in the circuit will be E by R. So it becomes B v0 L divided by R. So it will be the current in the wire. So because of this current, since it is placed in magnetic field, so magnetic field will apply a force opposing its motion in this direction. Okay, magnetic field will apply a force in this direction, and this force is basically ILB, because angle theta is 90, so it becomes ILB sin 90. We'll substitute the value of IB into V0 L divided by R into L into B. So magnetic force acting on this wire will be B square V0 L square divided by R. And in order to move this wire with a constant velocity, we must apply equal amount of force in opposite direction. So in order to maintain the constant velocity, external agent must apply a force of the same magnitude but in opposite direction. The magnitude of the force is B0 is B square V0 L square divided by R. So let us read out the options here. The thermal power dissipated in the resistor R is equal to the rate of work done by external person pulling the rod. As you can see, since the rod velocity is constant, here it is said that it is to be moved with constant velocity. Since velocity is constant, no change in kinetic energy is there. So whatever work is done by the external agent, that must be dissipated in the form of heat across this resistance. So this option is correct, but we have to find the incorrect option. Okay, so this is wrong because the option is correct. Second option, if applied external force is doubled, then part of external power increases the velocity of the rod, and that is obvious, because if we increase the force beyond the requirement, which is F magnetic, in order to maintain the velocity, then the rod will be accelerated, and because of this acceleration, kinetic energy is going to increase. So here it is said that if we double the external force, then part of external power increases the velocity of the rod. Yes, it is correct. So this is not right option because it is not incorrect. C option, if resistance R is double, then power required to maintain the constant velocity V0 becomes half. So first of all, what is the power required? Basically, the power required by the person will be F force multiplied with the velocity. So force is this and multiplied with the velocity, then it becomes this. In fact, power delivered by the person, this is power delivered by person. Okay, so power delivered by the person is inversely proportional to the resistance. Here we can see, so if resistance is double, then power required to maintain the constant velocity becomes half. So this is correct option. That means it is not correct. So option D will be the correct choice for this question, because we were supposed to find the incorrect option, and here all these three options were correct, so none will be our answer. Okay, so none of the above options are incorrect.